Hi, welcome to 3.4 Properties of Exponential Functions. Let's start with our success criteria. I can determine and describe key properties relating to domain and range, intercepts, increasing slash decreasing intervals, and asymptotes for exponential functions represented in a variety of ways. So the variety of ways means it could be in the form of a table, a graph, or an equation. Okay, let's begin with a little bit of context. You can see here in this picture, we have all these little electronic devices. These are actually all called capacitors. So capacitors are used in electric circuits, and basically what they do is they store up electric potential energy. And then once they store up and reach a certain point, they then discharge really, really quickly, giving a burst of energy. So they use this in applications like the flash on a camera. They use them in, smartphones, TVs, tasers, whenever you need like a sudden burst of energy. So I kind of relate these to those big buckets that you'll see in water parks. So those splash pads, so those buckets that fill up with water, and when the water reaches a certain point, they then tip and everything kind of spills out. Um, so basically, capacitors, what do they have to do with exponential functions? Well, it has to do with when they discharge. When they discharge that energy, their electric potential energy decays at an exponential rate. So any engineers that design and build these devices, they need to have a solid understanding of exponential functions. So usually they have a design requirement where it needs to discharge a certain amount at a certain rate. And so they then need to determine, what kind of capacitor they would need to use. Okay, so here's our first example. We won't be working with capacitors, but we're just going to be analyzing exponential functions. So I've copied a little bit of a summary from that first video. So hopefully you watched that first video that was in the class notebook. What it does is it really summarizes exponential functions that are in this form. So y equals ab to the exponent x. This is like really the most basic form of an exponential function. And if we understand the properties for this, we can really handle any other exponential function. So, so what's true about this? Well, we know what's true is that we know that the y-intercept is always going to be at the value of a. So the y-intercept will always have the point 0, a. That's because if you plug in 0 for x, this whole term goes to 1, and then you're left with just a. We also know that there is a horizontal asymptote at the line y equal to 0. So depending on the type of function, the function may be approaching the asymptote on the left side, or maybe it's approaching it on the right side. But either way, this thing can never equal 0. So there's no number you could put in for x, and then after you compute this, get 0. It does not exist. Okay, and lastly, the domain. The domain is x as an element of R. So for all these scenarios, every value of x is used in the graph. Okay, so there's no restrictions on x at all. Okay, what is a bit unique is actually the range for the graphs. So if you have a positive value for a and a base greater than 1, value of b greater than 1, then this represents growth. That's why the function is growing, and y will always be greater than or equal to 0. So anyway, I'm not going to kind of go through the rest of it. That was the purpose of the last video. So what we're going to do is we're just going to work on this example here. And what we're going to do is we're going to compare it to what we have in that chart. So it says graph each exponential function and then identify. So these are the two functions. We're going to graph them, and then we're going to identify the domain, the range, the intercepts, intervals of increase and decrease, and any asymptotes. When we get to intervals of increase or decrease, what they want to know is for what interval is the function increasing, or over what interval is it decreasing. So we'll talk more about that when we get there. Okay, let's begin with our first one, A. So I'm actually not going to graph it right away. I'm gonna use that chart here, everything in here, to help me get the graph. So if I compare this to this, um, I can actually see a few things. So I can already answer the domain. I know it's always going to be x is an element of R, so that's easy. The range, y is an element of R. And then now I know that my A value, I'll just write this in pink, A is 4 and B is the half that's here. So I have A is greater than 0, so it's going to be one of those. B is a half, well that means it's between 0 and 1, so it's got to be this graph here. So that means this is going to be a decreasing function and it's going to be positive. So my y values are going to be everything greater than 0, okay, like we got right here. So I'm just going to go ahead and write that in. We can say y greater than 0. I don't put the equal sign in here because remember it doesn't equal 0. Y does not equal 0. We have the horizontal asymptote there. Okay, next on the list, we need our intercepts. So are there going to be any x-intercepts? No, it doesn't cross. So x-intercepts, we're just going to write NA, not applicable. The y-intercept, there is one, and it's always going to be right here on the graph. What value is this? Well, this always works out to be A, right? That's our y-intercept. It's always the A value. So you could actually draw these in here. You could label them as A, the y-intercepts. Okay. All right, so we got 0, 4. And our intervals of increase and decrease. So this function, when I look at it from left to right, it's going down from left to right. So if you imagine you were walking along here from left to right, you would be going downward. So this is decreasing. Over what interval is it decreasing? Well, it's decreasing over the entire domain. All the way from negative infinity to positive infinity, this function is decreasing. The nice thing about exponential functions is they don't flip-flop. Okay, once they start decreasing, they're always decreasing. They don't change their mind and then start going up all of a sudden. So you're either going to have a decreasing interval or an increasing interval. So we could say decreasing, okay, and then we'll just state the interval. So decreasing, we can say over the entire domain. Okay, and if you want, you can state the domain again. You can say X is an element of R. Okay. All right, so we've done this, and this. And then lastly, just the asymptotes. So the asymptote is going to be a horizontal asymptote. I'm going to write at y equals 0. That's the equation of the line. Okay. All right, and that is true because this equation right here, no matter what you put in for x, it's never going to equal 0. And as x increases, this is going to get smaller and smaller and smaller, but never ever reach 0. Okay, so that's part A. Pretty easy when you have this nice handy summary sheet. I suggest you guys pause this video, copy this out, and then keep it handy for yourselves.